My name is Jose Cardenas, and I'll be talking about development of body cognitions, insights from children's concepts, and language processing. In this paper, we focus on developmental concepts of language processing and examine the importance of children's body experience for these aspects of cognition in particular. Following the review, we outline and we see the importance of environmental development issues that need to be addressed in order to determine the extent of which language and conceptual knowledge are embodied and to refine those theories of embodied cognition. Embodied cognition is a class of theories within cognitive science that emphasize the importance of sensory experience that gain through bodily interactions with the environment for attaining conceptual knowledge. Another two terms that are found in the article is disembodied end of the spectrum and strong embodied account. Disembodied states that sensory motors or experiences are not involved in cognitive, while strong embodied suggests cognition is constituted in action and sensory motor processing. So the importance of sensory-motor experience in development. So the general idea emphasized that in the development literature is that infants are embodied learners and use sensory-motor information to gain knowledge about our world. They develop a representational system as a result of earlier perceptual and motor interactions with their environment. Piaget proposed that as children continue to learn, they start to develop concepts that are independent of their sensory-motor experiences, and that sensory-motor interactions help improve their language processing and increase conceptual understanding. When children are getting sensory-motor experiences at a younger age, they have a higher order of cognitive functioning, and this allows their intellect and academic measures to be seen at a higher age level. Now going to concepts of nouns. So there was a study that Smith did with 2-year-olds who were introduced to an exemplar object called a wug, which the experiment labeled while moving the object either horizontally or vertically. Similar children were also given the opportunity to move the objects with themselves in the same direction or in others. Following this, children were asked to select the wug from two null objects, either the same height as the exemplar but extended horizontally, or the same diameter but extended vertically. For the children who manipulated the object themselves, there was an interaction between the direction they had moved the object and the object that was selected as the wug. Children who watched and then moved the wug horizontally chose the null object that was ascended horizontally, and vice versa. Going to the next concept with verbs. That is, a verb like give would be understood in empathy from concrete experiences of giving objects to parents or givers. The meaning would be grounded in these actions, so children's bodily actions towards other people are associated to understanding of abstract verbs such as love, and they don't appear to be grounded in one specific action. These verbs can be associated with verbally bodily behaviors that can help ground understanding of emotional content associated with verb meanings. Going to the next concepts of adjectives. The children were presented with two toys and asked for displaying specific property. The children were taught use adjectives using descriptive gestures performed better at test, and additionally, descriptive gestures were especially helpful at teaching adjectives that did not correspond to visual properties. That is, with observations of descriptive gestures more beneficial for teaching adjectives, where tactical experiences are essential to meaning as compared to adjectives where the meaning can be inferred through visual inspection. So the children who were taught with or viewing descriptive gestures use their sensory information and the test to affirm the gestures themselves and presumably to determine which objects fit the adjectives they were asked to identify. The next article that I chose was from Marley, Levin, and Glenberg, and the title is What Cognitive Benefit Does an Activity-Based Reading Strategy Afford Young Native American Readers? So the purpose of this article is that the author did two experiments with children in a reservation community. In the first experiment, there was 45 children that were randomly assigned to do different reading strategies and read, which were reread, observing, and doing activity. In experiment 2, they gathered 40 second grade children and were only to reread and do an activity strategy. The focus on the experiment was to discuss the instructional benefits from activity-based reading strategies and developmental implications. Going to the cognitive development, there is theoretical explanations of cognitive development provided by Bruner and Pidgeot and emphasize the importance of activity, imagery, and symbolic reasoning. There is an age-related difference in modality usage with younger children, deriving greater cognitive benefits when inactive repetitions are present. Going on from this view, we see that as children develop, they become more adept at representing their environment through iconic and symbolic modalities. Going to the concept of activity-based learning strategies, empirical investigations of activity-based learning strategies have consistently found improved memory for target information when activity is present. There were two potential theoretical explanations for memory improvement, one being neural encoding and other being episodic memory. An explanation for a motor encoding would be if reasonable if we were to say that a motor memory system is present that provides an additional pathway for encoding and for retrieving target information to and for long-term memory. While for episodic memory, memories for activity that once engaged in are contained in present relevant autobiographical memories. Going to context for visual and imagery, imaginal learning strategies. The way that we can explain their visual and imaginal learning strategies would be through using the dual code theory. According to the dual code theory, cognitive representations consist of verbal and nonverbal systems, with the two systems linked through inferential connections. Therefore, when a verbal representation of a concrete concept is presented, the nonverbal representation is expected to be activated in memory via the referential connections. In experiment 1, they gathered 25 boys and 20 girls from elementary school. They then randomly assigned to three instructional strategies: activity, observe, and read. Since they want the children to recollect all information they could remember from the story, there was a score system in which they got based on the information that they give. Zero being to no information, half for partial, and full point for most or all collection. For the first story of the students were shown toys that correspond with characters and objects in the three subsequent experimental stories. In the reread condition, the toys were covered with a blanket and they had to reread the story. In activity condition, they had to read, and the toys were moved or changed. In observe conditions, they had to read, but stop when given a signal, and they had to see the toys be moved away from the words. And the overall results from this is that participants in both the activity and observe conditions recalled more propositions than the participant in the read condition. The second article is the influence of bodily experience of children's language processing by Wellsby and Paxman that I found. The purpose of this is using the body-object interaction, and it measures how easily human body can physically interact with the words referent. They are used for adults, and they examine their language tasks and see if there's an accurate response for boy words. In the article, they examined these experiences with children, and they were given a word naming task with boy words. They investigate whether children's word naming performance is facilitated by boy or a semantic richness variable that allows assessment of the effects of bodily knowledge and children's word recognition. Going into aspects of sensory knowledge and conceptual processing, although have been previously shown to construct perceptual simulations of objects mentioned in sentences during language comprehension based on how the objects would be used and context implied. In a recent study, the development of this capacity for simulating the objects and context mentioned in sentences during language processing was examined. Children aged 7 to 13 either listened to sentences or viewed sentences from a computer screen and read them out loud. And at the end, participants were presented with a picture that either matched or mismatched the orientation implied with the sentence. There was further evidence where there was 9 to 12-year-olds and an age of adults who observed the movie of a person performing action pantomime, which is a mime performing with a hammer. They were then shown a photograph and asked to name what they saw in it. What they found with adults showed that the priming effect from the actions of the pantomimes, there was a larger priming effect with children than older children and the adults. Now, the boy measures, assesses people's perceptions of how easily a human body can physically interact with the object. The boy dimension draws upon previous body experiences interacting with objects. Facilitatory effects of boy have been observed with an adult population in Let's Go decision tests, phonological Let's Go decision tests, and semantic categorization tests. So the boy effect has recently been examined in adults using functional magnetic reasoning imagining. Furthermore, the more important high boy items were also associated with greater activations in the left inferior parietal lobe compared with low boy items. This area of the brain has been linked to kinesthetic memory and to functions such as the ability to plan and execute motor behaviors. High boy words refer to objects that can be interacted with more readily, and due to this relative differences and ease of interaction, richer sensory-motor simulations, and hence richer semantic representations are generated for these words. For word recognition system, in this model of the word recognition system, richer semantic representations gives stronger feedback to both orthographic and phonological units. Activity in the orthographic and phonological units provides the basis for responding in most words recognition tasks. For instance, word naming responses are sure to be generated primarily from the activation of phonological units. Richer semantic representations for high boy words produce stronger feedback for the activation of orthographic and phonological units, and thus faster response times in word recognition tasks. As such, the effects of boy observed thus far in the word recognition studies show that, at least for adults, that sensory motor knowledge is an important part of semantic representations of words, and this knowledge is relevant even in very basic tasks involving individual word recognition. The third article is by Smith LB and it's all connected pathways in visual object recognition and in early noun learning. The purpose of this article is that there's development is activity dependent change in a complex system. So Tango's successive causes and effects accumulate change over time and increase the structure and complexity over the developing system. He also mentions that within the complex systems, there's two outcomes, multi-causal, each being dependent on multiple causes, and there's often degenerate, that is more than one route to the same functional end. And in the article, he'll be illustrating the ideas between the links of the sensory motor development, visual object recognition, and word learning. For path one, there is a fundamental problem in visual object recognition and how the snapshot two-dimensional views that are input are integrated from expectations and representations of three-dimensional object shape. So there has been several recent theoretical proposals posit that three-dimensional views may be built from dynamic experiences of objects as they rotated around the elongated axis. This is important because once babies are able to hold and manipulate objects, they will start to show dynamically organized views of 3D things, and that will allow them to differentiate from 3D objects to 2D objects. When children are given objects, they start to examine and create planar views to determine how the object looks and how the different angles it has for the figures. For path 2 and 3, young children are able to recognize sparse geometric versions and is strongly correlated with productive vocabulary size and more strongly correlated with vocabulary than with age. So with these results, it suggests that in the changes in the visual representation of an object shape could happen between 12 to 36 months. Changes that appear to grow out of manual engagement with objects set the stage for rapid learning of objects' names. Learning object names also teaches children to attend to object shape and foster more abstract and category relevant representations of shape. So this teaching would allow children objects to be identified with the names and then it will be referred to categories while organized by the shape enhances to the attention of the shape. With path 4, it involves with the concept of action being played in the role of the real-time processes of stabilizing visual attention on an object and supporting the binding of a herd name to the seen thing. There has been evidence that showed that the holding object stabilizes the head of the newly walking infant. So head stabilizations may also stabilize and localize visual attention, and in doing so, support with visual learning. Experimental tests showed that adults can readily attend to one specific location without moving the eyes, and while the eye's gaze is fixated somewhere else. So thus, it creates a spatial tension, and adults is internal and does not require the moving the sensors towards the attended object. For path 5, the author gave head cameras to the babies while they interacted with the toys and played with their parents. They were able to have its perspective on the baby's view as the same thing when the baby analyzed the objects they had in their hands. When the baby is playing with the object, it is observing and getting a high dynamic view from the baby because they are observing the toy at a rapid time. However, there was still sometimes where there was visual stability. In these times there was visual stability, they were able to see the object better and get a better view from the head camera, this allowing them to get data on how they're able to receive the object when holding it in a steady pace. For the final path 6 and 7, when babies are playing with objects, they're substituting one object for another, and this is because they still haven't been able to properly have representations of objects and characterizations of words. The reason for this is because although there's difference that the adults can clearly spot out, for babies they're still referring to what they think is the object based on the relevant same shape and figure of the object. That's why when they have certain toys, they still have some confusion with knowing if they're playing with the same one because they still haven't been able to recognize them or categorize, and thus making them think that they still have the same object. Even when replacing the same object with another, if they still have the same texture, they think they will be playing with the same thing. That's why it's important for babies to have a lot of interactions so that when they get to develop, they are able to notice and start to use the cognitive process to determine what object is what and what words go with it. So this is the overall important and overall overtake of this articles and reading. So we've seen the importance of embodied cognition and how babies' cognitive process is able to process better when they are able to interact with objects and hearing parents or other people use the words. Babies use visual recognition in order to create mental representations and try to understand the object that they're holding, although they can't fully characterize object, at least be able to have a clue what it is. Also, using auditory recognition is important for them because when they playing with their parents, they get the word of the object repeated, so they try to recognize what it is. The same thing could be applied to children and adults, but since their cognitive process is better and they are more developed, they're able to identify and process faster. But even though there is still a faster processing development, having people to do an experiment with their visual skills are put to the test would be good for comparison's reasons. Also, there's people from all over the world, so there's bound to have different perceptions about objects and word meanings that would give to different results. Overall, while reading and answering the different concepts and experimenting that the authors conducted, experiment is interesting and can be collaborated or tuned to make different things. For example, if I were to conduct an experiment with my hypothesis would be how the stability and the visual recognition of people's interaction with objects and words could affect the baby's ability to understand their objective. Something that I will conduct about this is using the interpretation of auditory recognition and having it without the objects. This is a plan that I want to see if there are any changes if the babies get to know what the word is and then present the object afterwards to see if there are any changes. Also, having the head cameras on babies is good to get their perspective on how they interpret when they're given the objects in front of them. Another experiment would be trying to get the different factors between visual learning with interactions and auditory learning and get the interactions between those two because I feel like they both play an important part with how they get with when they are separated and stay focused on the only one criterion. The possibilities are endless, and however, the importance of environmental factors and interactions with that children and adults conducted can be very important because it helps with our cognitive process and helps with categorizing and mental representations grow faster.